In this video, we're going to look at everything that you need to know for Cambridge AS Level Mathematics 9709, Probability and Statistics 1, Representation of Data. Let's start with the measures of central tendency. The mean. The mean is the sum of all the values in the dataset divided by the total number of values. So to find the mean, we can say sigma x divided by n. Remember that sigma means the sum of. So, as an example, consider the value set below and determine the mean. To find the mean, all we do is add all of these values together and divide by the total number of values. There are 9 values in the set. So I can take my calculator. 2 plus 5 plus 8 plus 8 plus 11 plus 13 plus 22 plus 23 plus 27 divided by 9 is equal to 13,2. This is the mean of this data set. Now I'd like to look at the mode. The mode is the value that occurs most often. When working with grouped data, the modal interval has the highest frequency. Now we can move on to the median. When data values are listed in ascending order from smallest to greatest, the median is the value that lies directly in the middle. The way we find the median in a data set depends on whether we have an odd or even number of values. To find the median with an odd number of values, we say the position of the median is equal to n plus 1 over 2. To find the position of the median, add 1 to the total number of values in the set, and then divide by 2. Then, in the set, start with the lowest value and count that many places. This will be your median. Let's look at a very basic example. Determine the median in the data set below. We have 5 values. So I can say the position of the median is equal to n plus 1. N is 5, so I say 5 plus 1 over 2. 5 plus 1 is 6. Divided by 2 gives me 3. This is the position of my median. Now I start at the far left and I count 3 digits. 1, 2, 3. And I can see the median is equal to 5. When working with an even number of values, we can use this formula. Here, we divide the total number of values in the data set by 2. This will give you the position of the first value for the median. Then we add this to the value directly after it, and we divide by 2. Your answer will be the median of the data set. Let's look at another basic example. Determine the median in the data set below, and here we have 6 values. So I can say the position is equal to 6 over 2, which is equal to 3. Now I count up to the third term, 1, 2, 3, which is 7, and I need to consider the value directly after it. So 7 and 8. To find the median, I say 7 plus 8 over 2. 7 plus 8 gives me 15, divided by 2, and I get a median of 7.5. In this course, please remember that the median is always a better indication of measures of central tendency, as it is not affected by outliers. Outliers are extreme values. In your exam, you do not need to know about outliers or how to use them. Now I'd like to look at the range, quartiles, and interquartile range. Let's start with the range. The range is the difference between the highest and lowest values in the data set. Now let's look at quartiles. Quartiles divide a data set into 4 quarters. Q2 is the median, as it divides the data in half. The lower quartile, Q1, is the middle value between the lowest value and the median. the upper quartile, Q3, is the middle value between the median and the highest value in the dataset. To find quartiles, we can use the same formula for position as we do for the median. Always find the median first. For Q1 and Q3, the total number of items on either the left or the right of the median will show us Q1 and Q3. But when looking for these values, we do not include the median itself. Finally, let's look at the interquartile range. This is the difference between Q1 and Q3. So to find the interquartile range, we say the upper quartile Q3 minus the lower quartile Q1. Let's look at some examples of how we work with quartiles. Find the three quartiles and the interquartile range from the dataset below. In our set, we have 3, 6, 9, 11 values. So let's start by finding the position of the median Q2. So I can say the position is equal to n plus 1. N is 11, so I can say 11 plus 1 over 2. 12 over 2 gives me a position of 6. Now I start on the left hand side. 1, 2, 3, 4, 5, 6. 40 is my median, Q2. So I can say Q2 is equal to 40. Because 40 is an actual value in my set, I will not include this when I'm looking for my upper and lower quartiles. On either side of the median, I have 5 data values. So to find the position, I can say position is equal to n, which is now 5. 5 plus 1 over 2. 6 divided by 2 gives me 3. So from the far left side, I count 3 places, 1, 2, 3, and I see that Q1 is 15. To find Q3, I start directly to the right of the median, 1, 2, 3, and I see that Q3 is equal to 43. To find the interquartile range, I can say IQR is equal to Q3 minus Q1, 43 minus 15, which gives me an interquartile range of 28. Let's do one more example. In this data set, I now have 12 values. So I'm going to make a note up here that n is equal to 12. Let's start by finding the median. To find the position of the median for an even number of values, I say n over 2. N is 12, so it's 12 over 2, which gives me 6. Now I can start on the far left side. 1, 2, 3, 4, 5, 6. And I see that Q2 is equal to 10. So 10. But to find the median, I add 10 to the value directly to the right, which is 11. So 10 plus 11 gives me 21 divided by 2. And I see that Q2 is equal to 10,5. Because the median is not an actual value in my data set, I divide my set in half between these two values. Now on the left, I have 6 values and 6 on the right. To find Q1, I can say the position of Q1 is equal to 6 over 2, which is equal to 3. Now I count 3 terms, 1, 2, 3, and I see my 2 middle values are 4 and 4. I can say Q1 is equal to 4 plus 4, which is 8, over 2, which leaves me with a value of 4. This is my lower quartile. Now let's do the same thing on the right. count 3 positions, 1, 2, 3, I get 14, and the value next to it, 16, over 2. 14 plus 16 is 30, over 2 gives me 15. So this is the value of my upper quartile, Q3. Now to find the interquartile range, you can say IQR is equal to Q3 minus Q1, 15, minus 4, which gives me an interquartile range of 11. Now I'd quickly like to look at percentiles. A percentile is like a percentage. If we have 70%, we are working with the 70th percentile. A percentile divides data into 100 small sections. Just like we find a percentage, to find a percentile, divide the total number of data values by 100 and multiply by the given percentile. This will give you the position of the value. Percentiles don't seem to occur very often in this course, but they do pop up every now and again in the exams. So it is important to remember this, just in case. Now we can move on to the estimated mean, variance, and standard deviation. Let's start with the estimated mean. The mean can also be called the estimated mean, depending on whether you are working with individual data items or group data. It is easy to find the mean from a data set with individual values because we can just add them together and divide by the number of values in the set. But it is more difficult with grouped values because we may know which interval the data item lies in, but we do not know their exact value. We call the estimated mean EX, and to find the mean, we can use the following formula. Here, sigma XF is the sum of the data item multiplied by its frequency, and sigma F is the total frequency. So let's look at an example. The table shows the number of phones owned by families living on the same street. Estimate the mean number of mobile phones for each family. So I can say the estimated mean, EX, is equal to sigma XF. I need to multiply the number of phones by the relative frequency and then add these values together. 0 multiplied by 3 gives me 0. I don't need to consider that. 1 multiplied by 5 gives me 5. Plus, you can put this in your calculator. So I'm going to say 2 multiplied by 8 plus 3 multiplied by 10 plus 4 multiplied by 13 plus 5 multiplied by 7. And we divide this by the total frequency. 3 plus 5 is 8, plus 8 is 16, plus 10 is 26, plus 13 is 39, plus 7 gives us 46. So divide by 46. So let's put this into our calculator. 5 plus 2 multiplied by 8, plus 3 multiplied by 10, plus 4 multiplied by 13, plus 5 multiplied by 7 is equal to, divided by 46, gives us a mean of 3. This is our estimated mean. Now I want to look at data group by interval. We use the same formula for the mean, but now X is the midpoint of each interval. To find the midpoint of an interval, you can add the upper and lower bounds together and divide by 2. Let's look at an example. Sarah goes to a restaurant where 100 people are having dinner. She records her data as follows. Determine the estimated mean for the ages of the people in the restaurant. Before we can find the estimated mean, we need to find the midpoint for each interval. So in my table, I'm going to create a new column for the midpoint. 0 plus 10 is 10, divided by 2 gives me 5. 10 plus 20 is 30, divided by 2 gives me 15. 20 plus 30 is 50, divided by 2 gives me 25. And now I can see a pattern emerging. So the midpoint between 30 and 40 is 35, 40 and 50 is 45, 50 and 60 is 55, 60 and 70 is 65, and 70 and 80 is 75. My next step is to multiply every midpoint by its respective frequency. So I have 5 and 2. I can say 5 multiplied by 2. Then we're going to add 15 and 9. So I say 15 multiplied by 9 plus 25 and 15. 25 plus 15 multiplied by 15 plus 35 and 25. 35 multiplied by 25 plus 45 and 19 plus 55 multiplied by 16 plus 65 multiplied by 11 plus 75 multiplied by 3. And I can put this straight into my calculator. So I can say 5 multiplied by 2 plus 15 multiplied by 9 plus 25 multiplied by 15 plus 35 multiplied by 25 plus 45 multiplied by 19 plus 55 multiplied by 16 plus 65 multiplied by 11, and finally 75 multiplied by 3 is equal to 4,070. 4,070. Now we divide by the total frequency. And in this question, we can see that that is 100 people. So divide by 100, take my calculator, divide by 100 is equal to 40,7. This is my estimated mean. Now we can move on to variance. To find variance, we use the formula variance is equal to EX squared minus EX squared. Here, EX squared is the square of the mean. So all you need to do is find the mean and square it. We also have EX squared, where the square is inside of the bracket. To find EX squared, we square every X term, which is our midpoint, and then multiply by the respective frequency. Then we add all of these together and divide by the total frequency, like we did for the mean. Let's look at an example. Find the variance of the following data. We know that to find variance, we say variance X is equal to EX squared in the bracket minus EX squared outside of the bracket. Let's start with EX squared. All we need to do is square every X term and multiply it by its respective frequency. So I have an X term of 3. So I'm going to say EX squared is equal to 3 squared multiplied by its frequency, 2, plus 4 squared multiplied by its frequency, 5, plus 5 squared multiplied by its frequency, 8, plus 6 squared multiplied by 14, plus 7 squared multiplied by 9, plus 8 squared multiplied by 4. Let's write this down here, plus 9 squared multiplied by 3. Then we need to divide by the total frequency. So let's add these values together. You can use your calculator. 2 plus 5 plus 8 plus 14 plus 9 plus 4 plus 3 is equal to 45. So to find EX squared, I need to then divide all of these by 45. So let's put this into my calculator. I have 3 squared multiplied by 2 plus 4 squared multiplied by 5 plus 5 squared multiplied by 8 plus 6 squared multiplied by 14 plus 7 squared multiplied by 9 plus 8 squared multiplied by 4 plus 9 squared multiplied by 3 is equal to 1,742. Now divide this by 45 is equal to 1,742 over 45. This is our value for ex squared. I'm going to write this as a fraction. 1,742 over 45. Now I need ex squared. So we need to find the estimated mean ex. To find the mean, let's start by multiplying every x term by its respective frequency and adding these together. So I can say 3 multiplied by 2 plus 4 multiplied by 5 plus 5 multiplied by 8 plus 6 multiplied by 14 plus 7 multiplied by 9 plus 8 multiplied by 4 plus 9 multiplied by 3. Take my calculator. 3 multiplied by 2 plus 4 multiplied by 5 plus 5 multiplied by 8 plus 6 multiplied by 14 plus 7 multiplied by 9 plus 8 multiplied by 4 and finally plus 9 multiplied by 3 is equal to 272. I get 272. To find the mean, I divide by the total frequency, which I know is 45. I need the estimated mean squared. So I can put this into a bracket, squared. Now I can use this to find the variance. I can say variance is equal to ex squared, 1,742 over 45, minus the square of the mean, 272 over 45 squared. Take my calculator. 1,742 over 45 minus, let's open a bracket, 272 over 45, close the bracket, squared, is equal to 2,175, round off to 3 significant figures, and I see that my variance is 2,18. Please remember that these rules apply for grouped data with set intervals, except that x will be the midpoint of each interval. And now we can move on to standard deviation. Standard deviation is the square root of the variance. All the rules for a variance apply to standard deviation, except now we square root. So let's look at another example. Find an estimate of the standard deviation of the following data obtained in a test by 88 students. To find the standard deviation, I can say the standard deviation is equal to ex squared minus ex squared, all under a square root. Before we could find either of these values, we need the midpoint of each interval. 0 plus 10 is 10, divided by 2 gives me 5. 10 plus 20 is 30, divided by 2 gives me 15. Then I have 20 and 30, midpoint of 25. 30 and 40 has a midpoint of 35. And 40 and 50 have a midpoint of 45. These are our x values. So let's start by finding ex squared. I can say that ex squared is equal to find this, we square every x value and multiply it by its respective frequency. So I can say 5 squared multiplied by 6 plus 15 squared multiplied by 16 plus 25 squared multiplied by 24 plus 35 squared multiplied by 25 plus 45 squared multiplied by 17. Then we divide by the total frequency, and the question tells us that this is 88. We're going to divide all of this by 88. Now I can take my calculator and I can say 5 squared multiplied by 6 plus 15 squared multiplied by 16 plus 25 squared multiplied by 24 plus 35 squared multiplied by 25 plus 45 squared multiplied by 17. Now I can divide by 88 is equal to 10,475 over 11. I'm going to leave this in fractional form, and I'm going to make a note of this up here. Ex squared is equal to 10,475 over 11. Now I can make some space, and I'm going to look for ex squared. To find ex squared, all I need to do is find the estimated mean. So, to find the mean, we multiply every x value by its respective frequency and add them together. So I'm going to have 5 multiplied by 6 plus 15 multiplied by 16 plus 25 multiplied by 24 plus 35 multiplied by 25 plus 45 multiplied by 17. And to find the mean, we divide by the total frequency, 88. Take my calculator, and I can say 5 times 6 plus 15 times 16 plus 25 times 24 plus 35 times 25 plus 45 times 17 is equal to 2,510 divided by 88 is equal to 1,255 over 44. So now I'm going to make some space, and I can write my estimated mean as 1,255 over 44. But I want the estimated mean squared. So to make it easier, put this into a bracket, squared. Now I've got my two values. I can find my standard deviation. I can say my standard deviation is equal to ex squared, 10,475 over 11, minus the square of the estimated mean, 1,255 over 44, squared, all under a square root. And you can put this straight into your calculator. Let's create a root. Then we have create a fraction, 10,475 over 11 minus, let's open a bracket, 1,255 over 44, close the bracket, squared, is equal to 11,778 and so forth. Round off to 3 significant figures, and I see that my standard deviation is 11,8. Now I'd like to move on to how we find the estimated mean, variance, and standard deviation using given values. Please always keep in mind that if you are given a value of sigma x is the value of sigma xf, we are not given actual x values or frequencies, so you don't need to find anything else. If you are given sigma x squared, it is the value of sigma x squared f. We can use these values to find the mean, variance, and standard deviation. Let's look at an example. Find the mean and standard deviation of the sample, and we've been given three values: sigma x squared, and n, which is our total frequency. Let's start with the mean. I can say that the mean is equal to sigma x over the total frequency, which in this case is n. Sigma x is 960. I can say 960 over n, which is 60. Take my calculator. 960 divided by 60 is equal to 16. This is the estimated mean. Now I can find the standard deviation. We know that for standard deviation, we're going to say sigma x squared over n minus sigma x over n squared. And this is the square of the mean, all under a square root. Sigma x squared is 18,000. So I can say 18,000 over n, which is 60, minus the square of the mean, which I already know is 16. So 16 squared, all under a square root. Take my calculator. Let's create a root, create a fraction. 18,000 over 60 minus 16 squared is equal to 6,633, and so on. Round off to three significant figures, and I get a standard deviation of 6,63. Now I'd like to look at given values with brackets, and they will look something like this. Sigma with a bracket of x minus a, where a is a constant. To find the mean, we use the formula: the mean is equal to the value of sigma x minus a, all over n, plus a. And to find the variance, we can use this formula. But please be careful here. When working with brackets, we cannot use the mean, sigma x, when looking for the variance, because to find the mean, we take our fraction and we add a. But when working with variance, our squared term is simply the fraction. Keep this in mind in your exam. We have seen questions like this every single year so far. Finally, last thing to remember is that the standard deviation is still simply the square root of the variance. Let's look at an example. For a set of 10 data items, sigma x minus 9 is equal to 7, and sigma x minus 9 squared is equal to 17. Find the mean and the standard deviation. Let's start with the mean. You can say that the mean is equal to sigma, the bracket of x minus a, over n, plus a. In this case, our a value is 9. So I can say sigma x minus 9. The question tells me that that is 7. So 7 over the total values in the set, 10. 7 over 10 plus my a value, which is 9. Add these together and I get 9 and 7 over 10. Now I can find the standard deviation. So I can say the standard deviation is equal to sigma x minus a squared over n minus sigma x minus a over n, all squared, all under a square root. The question tells me that sigma x minus 9 squared is 17. So I can say 17 over n, which is 10, minus sigma x minus 9, which I know is 7 over 10, a bracket squared, all under a square root. Now I can put this into my calculator. I can say the square root of 17 over 10 minus, let's open a bracket, 7 over 10 squared is equal to 11 over 10, which gives me a standard deviation of 1, 1. I can write my answer over here. Now I'd like to look at how we work with more than one set of values. If you are given more than one set of values, we use this formula to find the estimated mean, and you can use this one to find the variance. To use these formulae, the A values have to be the same in both sets of information, and the N values are the total items in each set of data. So let's look at an example of how we work with this. Here we are given a summary of 20 values of x and a summary of 25 values of x. Part A says find the mean of all 45 values of x. So let's make some space. To find the mean of all 45 values, we can say that the mean is equal to the value of sigma x minus a from our first set plus sigma x minus a from our second set, all over the total number of values in set 1 plus the total number of values in set 2 plus the value of a. Here our a value is 30. So from set 1, sigma x minus a is 439, let's say 439, plus from the second set, 417, all over. The question tells us that the total number of values is 45. I can say over 45 plus a, which is 30. Now I can put this into my calculator. I can say 439 plus 470 divided by 45 plus 30 is equal to 50,2. This is my mean. And now we can look at part B. Find the standard deviation of all 45 values of x. To find the standard deviation, I'm going to say sigma x minus a squared for our first data set plus sigma x minus a squared for the second over the total number of data set values minus sigma x minus a for my first set plus sigma x minus a for my second set over the total number of values. Put this into a bracket squared, and then I'm going to try and squeeze it in, all under a square root. Just remember that this is not the square of the estimated mean. Let's fill in our values. Sigma x minus 30 squared from the first set, 12,405, plus square bracket from the second set, 11,346, over the total number of values, 45, minus the value of the bracket from the first set, 439, plus the bracket from the second set, 470, over the total number of values, 45. Let's put this into a bracket squared, all under a square root. And now I can take my calculator. Let's take a square root I'm going to create a fraction. I can say 12,405 plus 11,346 over 45 minus, let's open a bracket, let's create a fraction, 439 plus 470 over 45, let's close my bracket, squared, is equal to 10,9434. Let's round off to 3 significant figures. And I can see that my standard deviation, I'm going to write it up here, is equal to 10,9. Let's do one more example. Here we are given the summary of 50 values of x, where q is a constant. Part A says find the standard deviation of these values of x. So let's start here. To find the standard deviation, we can say that standard deviation is equal to sigma of the square bracket x minus q squared over n minus sigma bracket x minus q over n all squared under a square root. And now we can fill in our values. Our square bracket, 14,235. Put this down here, 235. N is the total number of values, 50, so over 50. Minus the value of the non-squared bracket, 700 over 50. Let's put this into a bracket squared, all under a square root. Now I can take my calculator. Let's create a root and a fraction. 14,235 over 50 minus, let's open a bracket, create a fraction, 700 over 50, close the bracket, squared, is equal to 9,418 and so on. Round off to 3 significant figures, and we see that the standard deviation is 9,42. And now we can do part B. Given that sigma x is 2,865, find the value of q. To find the value of q, we need to use the formula for the estimated mean. We know that the mean is equal to sigma x minus q all over n plus q. And the reason why we have to use this formula is because it is the only way to isolate the value of q. The only other information that we can work with is that sigma x is equal to 2,865. So I can say that sigma x is equal to 2,865. But sigma x is the total number of x values multiplied by their respective frequencies. This is not a value for the mean. However, to find the mean when we have data in this format, is all we do is divide by n. We know that n is 50. So to find the mean for this value, we divide by 50. Now we have the mean and the equation for the mean again, which means that these two are now equal to each other, and we can use this to find the value of q. So we know the value of the bracket, 700 over n, which is 50, plus q, is going to give us a value of 2,865 over 50. And now we can solve for q. To make it easier, make q the subject. Get q is equal to 2,865 over 50. And we move our other fraction to the right, minus 700 over 50. Now I can take my calculator. Both of these fractions have the same denominator. So I'm going to say 2,865 minus 700 over 50 is equal to 43,3. This is my value for Q. So you can say Q is equal to 43,3. Now I'd like to move on to stem and leaf diagrams. In your examination, you may be required to draw a back-to-back stem and leaf diagram. This is not in every paper, but we have seen these diagrams come up more than any other representation. Values in the stem are written downwards in ascending order. Values in the leaves are written outwards in ascending order. Each value in the leaf must be a single digit. The values you are working with will determine the number of values in the stem. So as an example, if you're working with 20s, you can put 20 in your stem and 7 in your leaf for 27. Or you can put a 2 in your stem and 7 in your leaf. But if you have something like 127, you have to put 12 in your stem because you can only have a single digit of 7 in your leaf. Always include a key along with your diagram. This shows the reader what each value means. So as an example, I can say a key of 235 means 32 on the left and 35 on the right. You can choose any combination of values for your key. With this in mind, let's have a look at some examples of how we work with stem and leaf diagrams. The times taken in minutes to complete a cycle race by 19 cyclists from each of the two clubs, the Cheetahs and the Panthers, are represented in the following back-to-back stem and leaf diagram. Part A says find the median and interquartile range of the times for the Cheetahs. There are 19 cyclists, so to find the median, we can say the position for an odd number of values is equal to n plus 1 over 2. N is 19. 19 plus 1 is 20. Divided by 2 and we get 10. So the median, Q2, sits in the 10th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Q2 is 99. I'm going to make a note of this up here. The median Q2 is equal to 99. Because we've used an actual value, we cannot include 99 in our data set when looking for Q1 and Q3. We had 19 values. We've taken out 1, so we're left with 18. Half of 18 is 9. That means we now have 9 values on either side of the median that we can consider for Q1 and Q3. If n is 9, position of Q1 is equal to 9 plus 1, which is 10, over 2, which is equal to 5. So to find the position of Q1, well, actually to find the value of Q1, we can say 1, 2, 3, 4, 5. Q1 is 83. I'm going to make a note of it down here. Q1 is equal to 83. Now to find the upper quartile Q3, we count 5 values after the median. 1, 2, 3, 4, 5. And I can see that Q3 is equal to 106. To find the interquartile range, I can say IQR is equal to Q3, 106, minus Q1, 83, which is equal to 23. And now we can move on to part B. The median and interquartile range for the Panthers are 103 minutes and 14 minutes respectively. Make 2 comparisons between the times taken by the Cheetahs and the times taken by the Panthers. Now, you can make any two comparisons that you would like to, as long as you can justify them using the data you've been given. My best suggestion, the best two things to look at are the values of the medians and the values of the interquartile range. We just found that the median for the cheaters is 99. And this question tells us that the median for the Panthers is 103. The median is the best indicator of central tendency. So here we can see that the cheaters were quicker than the Panthers. And we can make a note, one of our comparisons, that the cheaters are faster than the Panthers. Another thing to look at is your interquartile range. The cheaters have an interquartile range of 23 and the Panthers of 14. The data for the cheaters is more widespread, which means they had quicker cyclists and slower cyclists. So as our second comparison, we can say that the times for the cheaters are more spread out than the times for the Panthers. And we've now included two justifiable comparisons. Let's move on to part C. Another cyclist, Kenny, from the cheaters, also took part in the race. The mean time taken by all 20 cyclists from the cheaters was 99 minutes. Find the time taken by Kenny to complete the race. We know that to find the mean, we need to add all of our data values up and divide by the number of values in the set. So in other words, if we take all of our values for the cheaters in our diagram, add them all together, so I'm just going to say the sum of x, plus Kenny's value, and divide by, now we have 20 cyclists, let's divide by 20, we're going to get the value of the mean, which we now know is 99. We are going to use this to find Kenny's time. We need to add all of the values in the stem and leaf diagram together. So I'm going to take my calculator. I've got my lowest value, 78, plus 79, plus 80, plus 82, plus 83, plus 87, plus 88, plus 97, plus 98, plus 99, plus 101, plus 103, plus 103 again. Then I have 105, 106, 112, 118, 119, and 124, which gives me 1,862. So now I can see that 1,862 plus Kenny's score over 20 will give me a mean of 99. Let's multiply both sides by 20. 99 multiplied by 20 is equal to 1,980. So 1862 plus K is equal to 1,980. To find K, let's subtract 1,862 from both sides. And say minus 1,862 is equal to 118. This was Kenny's time. So up here, I'm going to say that K is equal to 118. Let's do another example. Teams of 15 runners took part in a charity run last Saturday. The times taken in minutes to complete the course by the runners from the Falcons and the runners from the Kites are shown in the table. Part A says draw a back-to-back stem and leaf diagram to represent the information with the Falcons on the left-hand side. The first thing we need to do is put in our titles. So let's put the Falcons on the left and the Kites on the right. We start with our central column. the stem of our diagram. In the table, the lowest value is 32 and the highest is 76. So we need to account for 30s, 40s, 50s, 60s, and 70s. We can draw in our column like this. Now we need to include the values for the falcons. The lowest value is 38. So over here we can say we have 30, let's say 8. Then we have 39. 40s, we have 42, 44, 46, and 48. Then we have 50, so we put 0, 51, 52, 56, 58, and 59. For the 60s, we have 64 and 69. And for the 70s, we have 76. Now we can do the same thing for the kites. The lowest value is 32. So our 30s column, we have 2. For our 40s, we have 2 40s, 45, 47, and 48. In the 50s, we have 52, 54, 58, and 2 values of 59. For the 60s, I have 0, 1, 3, and 5. And this is my stem and leaf diagram. But don't forget your key. You use your key to show your marker exactly what you're trying to say. You can use any combination of values. I'm going to use these 3 up here. So I can say the key of 832 shows 38 points for the falcons and 32 points for the kites. And now we can look at part B. Find the median and the interquartile range for the times for the falcons. Let's start with the median. We're going to use our table from part A. There are 15 runners. It's an odd number. So to find the position of the median, I'm going to say n plus 1 over 2. 15 plus 1 gives me 16. 16 divided by 2 gives me 8. Let's look at the falcons. 1, 2, 3, 4, 5, 6, 7, 8. So Q2 is 51. So over here I can make a note that the median Q2 is equal to 51. To find the interquartile range, I need the value for the lower quartile Q1 and the upper quartile Q3. We used 51 as the median. We cannot include this value again. We had 15 runners. We now have 14 divided by 2, and we have 7. So for the position of Q1, I can say 7 plus 1 over 2. 7 plus 1 is 8. Divided by 2 gives me 4. Start with the lowest value. 1, 2, 3, 4. So 44 is our Q1. So I can say the lower quartile, Q1, is equal to 44. Now I can find the upper quartile, Q3. 1, 2, 3, 4. 59 is my upper quartile. Let's make a note of this over here. Q3 is equal to 59. The interquartile range is the difference between Q1 and Q3. So I can say the interquartile range is equal to the value of Q3, 59, minus the value of Q1, 44, and I get an interquartile range of 15. Now I'd like to move on to the Box-and-Whisker plot. A Box-and-Whisker plot looks like this. For this diagram, you need the following values: the minimum value, the lower quartile Q1, the median Q2, the upper quartile Q3, and the maximum value. If a plot is skewed, the direction of skewness is always the side with the longer tail. So let's look at an example of how we work with these plots. The back-to-back stem and leaf diagram shows the diameters in centimeters of 19 cylindrical pipes produced by each of two companies, A and B. When you're looking at a stem and leaf diagram, pay attention to the key, because it is easy to assume here that 334 is 334, but the key shows us that 351 is 0,351, which means 334 is actually 0,334. Part A says find the median and interquartile range of the pipes produced by Company A. There are 19 pipes. 19 is an odd number. So to find the position of the median, we say 19 plus 1, which is 20, divided by 2, which gives us 10. Now, for Company A, let's start with the lowest value and count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 355. So the median, Q2, is equal to 0,355. The question also wants us to find the interquartile range. So we need the values of Q1 and Q3. We've already used 0,355. We can't use it again. I'm going to scratch it out. We now have 18 values left. 18 divided by 2 gives us 9. There are 9 values on either side of the median. 9 is odd. 9 plus 1 gives us 10. Divided by 2 gives us 5. So the lower quartile, Q1, will be the term in the 5th position. 1, 2, 3, 4, 5. So we can see that Q1 is equal to 0,348. Now let's find the upper quartile, Q3. Starts after the median, and we count 5 units. 1, 2, 3, 4, 5. So we can see that Q3, I'm going to write this over here, is equal to 0,366. To find the interquartile range, we find the difference between Q1 and Q3. So I can say the interquartile range is equal to the value of Q3, 0,366, minus Q1, 0,348. Take my calculator. 0,366 minus 0,348 is equal to 0,018. This is my interquartile range, 0,018. And now we can move on to part B. It is given that for the pipes produced by Company B, the lower quartile, median, and upper quartile are 0,346, 0,352, and 0,370 centimeters respectively. Draw Box-and-Whisker Plots for companies A and B on the grid below. And here we have our grid. Before we can draw our plots, we need specific values for Company A and Company B. The lowest value, quartile 1, quartile 2, quartile 3, and the highest value. So let's make some notes about Company A. In part A, we found Q1, Q2, and Q3. So all we need now are the lower and higher values. So let's go back and have a look at our stem and leaf diagram. The lowest value is 0,334 and the highest is 0,374. So now let's make some notes. I can say the lowest value is equal to 0,334. From part A, I know that Q1 is 0,348. I know the median Q2 is 0,355. Q3 is equal to 0,366. And we know that the highest value is 0,374. Now we need details for company B. The question gives us Q1, Q2, and Q3, but we still need the lowest and highest values. So let's go back to our stem and leaf diagram. The lowest value is 0,331, and the highest is 0,388. So let's make a note of this quickly. I can say the lowest value, 0,331, and the highest value, 0,388. Now that I have these values, I can draw my Box-and-Whisker plot. We need to draw plots for company A and company B on the same graph. So let's divide our graph into two. Before we can draw our actual graph, we need to include values along the x-axis. The lowest value is 0,331 and the highest is 0,388. Use as much of your graph as possible and make sure that your intervals are evenly spaced. So in this case, I'm going to create intervals from 0,33 to 0,39. And now I can plot my points. Company A. Let's put company A at the top of the graph. The lowest point is 0,334. That will sit about here. Then I have 0,348. Plot that around there. Then 0,355. That will sit halfway between 3.5 and 3.6. So over there. 0,366. That will sit about here. And the highest value, 0,374, which will sit there. Now I can draw my box, draw in my left tail and my right tail. You need to make sure that your marker knows which company each box is for. So let's label this as company A. Now we can start plotting points for company B. B has the lowest point, 0,331. Let's plot this over here. The question gives us Q1, Q2, and Q3. Q1, 0,346. Let's plot that point. Q2, 0,352. Let's plot this point. The upper quartile, 0,370. That will sit over here. And the highest value, 0,388. So let's plot this point. Now, once again, let's draw in our box. I can sketch in my left tail and my right. This box is for company B. So let's label this as well. And now we can take out our dotted line and we have finished our Box-and-Whisker plot. Now we can move on to part C. Make one comparison between the diameters of the pipes produced by companies A and B. You can use your Box-and-Whisker plot to help you find a comparison. So over here, we can see that the box for company A is a lot narrower than the box for company B. So as my comparison, I'm going to say that the diameter of company A's pipes are more consistent than company B. Now I'd like to look at histograms. A histogram is like a bar chart, except the bars touch each other. If the lowest value in the first interval is not 0, leave a gap in your diagram between the y-axis and the first bar. Remember that class intervals lie along the x-axis. The frequency is the area of the bar, so the frequency density lies along the y-axis. To find frequency density, we divide the frequency by the range of each class interval. Don't forget to label both of your axes. You will lose marks in your exam if you don't. Always keep in mind that histograms consider continuous data. So x is greater than or equal to 10 and smaller than 20, or greater than and equal to 20 but smaller than 30. If intervals are not continuous, then you need to add 0.5 to the upper and lower bound of each interval. Watch out for this in your exam. Let's look at an example of how we work with a histogram. The heights in centimeters of 200 adults in Burundi are summarized in the following table. Part A says, draw a histogram to represent this information. Now, before we can draw the histogram, we need the frequency density, so we know how high to draw our bars. To find the frequency density, we divide the frequency by the length of each interval. So let's make some notes. We can say the frequency density. For the first column, we have a frequency of 16. 130 to 150 gives us a length of 20. Take your calculator. 16 divided by 20 is equal to 0.8. This is the frequency density for our first bar. Then we have 50 to 160. That's 10 units. So I can say the frequency of 32 divided by 10 is equal to 3.2. Let's put this in here. For the next interval, 160 to 170, the interval has a length of 10. 76 divided by 10 gives us a frequency density of 7.6. Then we have 170 to 175. The length is 5 units. So I can take my calculator. Say 64 divided by 5 is equal to 12.8. That's the height of my next bar. And finally, 175 to 195 is an interval of 20 units. 12 divided by 20 gives me a frequency density of 0.6. Now that I have these values, I can draw my histogram. So let's put in our graph. We need to number our x intervals. Here we are looking at heights between 130 and 200. So I'm going to put 130 to 200 along my x-axis. Use as much of your graph as you can. Just make sure to keep your intervals even. My first interval starts at 130, and there should be a large gap between 0 and 130. But to account for this in an exam, we simply put a zigzag line like this to show your marker that you know there is a big gap, but we obviously don't want to waste space. This is our x-axis, so let's label it as heights. Now we can look at our y-axis. Our y-axis considers frequency density, and we know that we are considering frequency densities between 0.6 and 12.8. So I'm going to label my y-axis from 0 to 14. Don't forget to put in your label. So over here, I can say frequency density. And now I can draw in my bars. Heights between 130 and 150 centimeters have a frequency density of 0.8. So let's draw this bar in like that. From 150 to 160, I have a frequency density of 3.2. So I can draw this bar. 160 to 170 has a frequency density of 7.6. So this bar is going to be high to up there. Then 170 to 175 has a frequency density of 12.8. So not only is this bar going to be narrow, it's going to be high as well. And finally, 175 to 195 centimeters has a frequency density of 0.6. And I can draw this bar in like that. And I've now completed my histogram. Now I can move on to part B. The interquartile range is R centimeters. Show that R is not greater than 15. We know that quartiles divide data into quarters. Here we can see the total number of adults is 200. To find the interquartile range, I need Q1 and Q3. So to find Q1, I can say 200 multiplied by 1 over 4, and I get 50. Q1 is the value in the 50th position. To find this value, we cannot find the exact value because we are working with intervals, but we need to determine the interval that this value will lie in. So all we do is we start counting the frequencies until we reach 50. 16 plus 32 gives us 48. This is just smaller than 50. But if we add 76, we will get a value larger than 50. So we can see that quartile 1 will lie between 160 and 170. So I can say that quartile 1 is equal to 160, smaller than or equal to h, which is smaller than 170. Now I need to do the same thing for quartile 3. Q3 is 3/4 of the way up in terms of values. So I can say 200 multiplied by 3 over 4, and I get 150. Now I can count my frequencies until I reach 150. 16 plus 32 gives me 48, plus 76 gives me 124, plus 64 gives me 188. So I can see that Q3 will lie in this interval over here. So I can say that Q3 is equal to 170, smaller than or equal to h, which is smaller than 175. We know that to find the interquartile range, we say the value of Q3 minus the value of Q1. When working with continuous data, we need to use the intervals. But in cases like this, for Q3, we use the highest value of the interval, and for Q1, we use the lowest. So now, in this case, I can say that R is equal to 175 minus 160, which is equal to 15. R is equal to 15. It is not greater than 15. So this is my final answer. Finally, I'd like to look at cumulative frequency. Let's start with a cumulative frequency table. A cumulative frequency table is a running total. The frequency of each interval is the sum of the frequency of that interval and all intervals before it. The frequency of the interval in the far right column is always the total frequency. Now let's look at the cumulative frequency graph. Cumulative frequency runs along the y-axis and the given intervals run along the x-axis. Make sure to label both of them on your diagram. To plot points on a graph, we use the highest value in each interval, and then we join our points to draw the curve. The curve does not need to be exact. Just make sure that your points are plotted correctly. To determine the median and quartiles from a cumulative frequency graph, divide the cumulative frequency by 4. So let's say the cumulative frequency is 200. We divide by 4 and we get 4 quarters, 50, 100, and 150. Then we draw horizontal lines from the y-axis until they touch the graph. From the graph, draw vertical lines down to the x-axis. This will give you the values of the median and the given quartiles. Let's look at an example. The time taken in minutes to walk to school was recorded for 200 pupils at a certain school. These times are summarized in the following table. Part A says draw a cumulative frequency graph to illustrate the data. Let's start by drawing in our graph. Now for any graphs, be it your cumulative frequency, your histogram, it doesn't matter. Use as much space as possible, but also make sure that your intervals for your x and y axes are evenly spaced. So here I have 1, 2, 3, 4, 5, 6, 7, 8 blocks. My x-axis considers my intervals, which in this case is time. I have t values between 0 and 70. So I'm going to put intervals between 0 and 80 along my x-axis. Label both axes. So over here, I'm going to squeeze this in and say time taken. Now let's look at our cumulative frequency. We are working with 200 students. I have 1, 2, 3, 4, 5, 6, 7, 8 blocks. So to keep these evenly spaced, I'm going to do intervals of 30 from 0 to 210. Again, make sure to label your y-axis. So you can say cumulative frequency. And now I can plot my points. My first interval goes up to t is 15. So let's plot this point over here. My second interval goes up to a time of 25 minutes and cumulative frequency 46. So let's plot this point. For my next point, time of 30 will sit over here. Time of 40 will sit about there. Time of 50 over here. And when t is smaller than or equal to 70, it will sit over here. Now I can join my points and draw my graph. This is all you need to do for a cumulative frequency graph. So now let's move on to part B. Use your graph to estimate the median and the interquartile range of the data. We know that the cumulative frequency is 200. Divide 200 by 4 and I get 50. This means that Q1 is when the cumulative frequency is 50. Q2 must be when it's at 100. And Q3 must be when it is equal to 150. The best way to find the actual values of Q1, Q2, and Q3 is to use your cumulative frequency graph. So let's draw this back in over here. I know that at Q1, the cumulative frequency is 50. So I can draw a horizontal line from the y-axis to the graph. Let's make a note that this is 50. Now I draw a line down from the graph to the x-axis. This line touches the x-axis when x is 26. This is my value for Q1. So let's make a note of this over here. Now let's find the median Q2. At the median, cumulative frequency is 100. So I need to draw my line around here. Let's make a note that it's 100. Now I can draw my vertical line down to the axis. This line touches the axis when x is 33. This is the value of my median Q2. And I can make a note of this as well. Finally, let's find the value of Q3. For Q3, the cumulative frequency is 150. So I can draw my line from 150 to the curve and then down to the x-axis. This touches the axis at 42. So let's make a note that Q3 is equal to 42. Now we can go back to our question. The graph wants us to find the median, which we know is Q2. So I can say that Q2 is equal to 33. We also need the interquartile range. We know that to find the interquartile range, we say Q3 minus Q1. We know that Q3 is 42. I can say 42 minus Q1, which I know is 26. And I see that my interquartile range is 16. And now I can move on to part C. Calculate an estimate for the mean value of the times taken by the 200 pupils to walk to school. To find the estimated mean, I'm going to write this over here. The estimated mean, we say, is equal to sigma xf over sigma f. We know that sigma f is the total frequency, the cumulative frequency, 200. but we still need to find sigma xf. X is the midpoint of each interval, and f is the frequency of each interval. So before we can find the estimated mean, we need to find our midpoints and the respective frequency of each interval. So let's start with the intervals. Our first interval considers t values between 0 and 15. Then values between 15 and 25. Values between 25 and 30. Values between 30 and 40. Values between 40 and 50. And then values between 50 and 70. Let's tidy this up. Now we can find our midpoints. The midpoint between 0 and 15 is 7,5. 15 and 25 is 20. 25 and 30 is 27,5. 30 and 40 is 35. 40 and 50 is 45. And 50 and 70 is 60. We have our midpoints, but we still need the frequency of each interval. To find the frequency of any interval, we subtract the frequency directly before it. So for our first interval, simply 18. For our second interval, we say 46 minus 18, which gives me 28. For our third interval, 88 minus 46, which gives me 42. 140 minus 88 gives me 52. 176 minus 140 gives me 36. And 200 minus 176 gives me a frequency of 24. Now I have my midpoints and I have my frequencies. So now I can find the estimated mean. To find sigma xf, I need to multiply each midpoint by its respective frequency and then add these values together. So I can say 7,5 multiplied by 18 plus 20 multiplied by 28 plus 27,5 multiplied by 42 plus 35 multiplied by 52 plus 45 multiplied by 36 plus 60 multiplied by 24. To find my estimated mean, I still need to divide this by the cumulative frequency. So I'm going to put this into a bracket and I'm going to say divided by 200. Now I can put everything into my calculator. So I have 7,5 multiplied by 18 plus 20 multiplied by 28 plus 27,5 multiplied by 42 plus 35 multiplied by 52 plus 45 multiplied by 36 plus 60 multiplied by 24 is equal to, let's divide by 200, and I get 33,65. This is my estimated mean, 33,65, and this is my final answer.